Okay, welcome. This is just a short tutorial on how to identify normal forms in a database design. Okay, so it's full of rules and you're really going to have to know the rules to be able to make any sense of this. So let's just begin. Okay, so the idea is that there's some rules. And assume that you've been given a database that's in horrible shape. And it's got all sorts of violations on it. And your job is to go through and identify the violations, and then after you've identified them, you can go in there and make the fixes. So step one in fixing a broke database is to identify what's wrong. That kind of makes sense. So that's what we're going to do. So you get a table and you go through these things called normal forms. That's a term that the database people use. And there's a set of rules, and you just go through them in order. And the first one is, does it meet the definition of a relation? And then we go through first normal form and second normal form, all the way through. So let's just start with the rules. The first one is, what the heck is a relation? Well, the term relation is kind of an unusual one in the database world. It talks about a set of rules. Basically, there's 8 rules. And let's just go through them. The first rule basically is that the table that we're talking about only contains information about one thing. That's kind of what it's all about. And that a single row on that table contains information about a single thing. In other words, you can't have one row that has like 2 students in it. Makes sense, right? So if you had a table for students, every row is just one student. You can't have student number 1, then student number 2, and then student number 3, and student number 4. Make sense? Okay, cool. And then the next rule is like every column in a table has to have stuff that's somehow directly related to the topic. And that one is a little weird, and we'll go into that one a little bit later. So for example, if this is a student table, I'd expect to have the students, first name and last name and what their major is and maybe what their grade point average or something. But I wouldn't expect to find like the room number for the class that they're taking, because students don't have room numbers. Okay, that's basically what that means. The next one talks about that if you have a column in, like, let's say you have a column in an Excel spreadsheet. In an Excel spreadsheet, you could have numbers and text and all sorts of things in there. But in a database, you pick one particular data type, and everything in that column has to keep that data type. So if you pick number, it's going to be numbers forever. If you pick text, it's going to be text forever. That's what that means. Every cell, every combination of a row and column, contain information about just one thing, not 2 things. Okay, so you can't have multiple things being shared in a particular cell. And the next couple are kind of weird. It basically says that you can't depend on the rows being in any particular order, and you can't depend on the columns being in any particular order. And then lastly, you can't have any duplicates. Okay, the most important one when talking about normal forms is that second one, where all columns contains data related to a single entity. All right, so let's do an example. So here's an example of a horrible design. I got student ID, first name, last name, major, student type, and phone. So let's see how many violations we can find. So right off the bat, I have inconsistent data types. Clearly, some of these are numbers and some of these are text. That one's easy to spot. How about the rule for the cell can't have more than one value? There's a good one there. How about row order? I told you that the rows can't be in a particular order, so William Bonin has 2 phone numbers, and they just wrote the second one underneath. But there's no guarantee that this row is always going to be immediately after that row, so that's not going to work. And then lastly, I actually have a duplicate. I got John Doe Math and John Doe Math down here, so I actually have a duplicate. So that's kind of a simple example of how to use the relation rules to see if a table meets those rules. Okay, so that's not too difficult, is it? The worst one, the most complicated one, is the one we're going to be talking about an awful lot. So let's move on to first normal form. So a first normal form is not really anything special. All it basically says is that the table is already a relation, which means those 8 rules already apply, plus it has a primary key. Now, just as a review, primary key means some sort of a key that you have designated that can uniquely identify a row. So that's really just a practical application of that last rule in the relation that says you can have 2 rows that are the same. The practical way you do that is through a primary key. Okay. Now this talks about, there's a term they use to describe this. It's called a functional dependency. And a functional dependency is a kind of a strange thing. Basically what it says is, if you give me one piece, I'll be able to tell you something else. So to test whether something has a functional dependency, just say it out loud. Given a student ID, like a primary key, I should be able to tell the first name and the last name and the major. That sounds right, doesn't it? But given a student ID, I should not be able to tell the room number for the class he's currently attending. Not directly, because students don't have room numbers. Students have first names and last names, but they don't have room numbers. Make sense? Okay, that's the most complicated part. And the functional dependency, again, the concept is not tough. It's just that the idea of everything has to be related. That's the fundamental thing on a first normal form violation. So, given an employee ID, I should be able to tell the name, address, title, position, all sorts of things about the employee. Let's do an example. So, here we go. Here's a stock inventory of some sort. And I have an item number. And so item number 12 is a kumquat. And I have a unit price and the quantity on hand. And I have a customer and order. So, say it out loud. Given an item number, a stock number, should I be able to tell the description of the product? Yeah. If you gave me a stock number, I should be able to tell you what the product is. Should I be able to tell you what the unit price is? Yeah. How about the quantity on hand at the grocery store? Yeah. I go along with that. But given an item number, should I be able to tell the customer? The customer's name? No. So, this item is the primary key. The description, that's fine. Unit price, that's fine. Quantity on hand, that's fine. But no, the item number does not determine, that's the functional dependency term, does not determine the customer. And it doesn't determine the order number. Now, we're not saying that you don't need this information, the customer and the order number. We're not saying, oh, we need to eliminate that. What we're saying is you need to move it someplace else. Okay? Cool. So, this might look subjective. Just looking at it, going, you could go, well, yeah, it could or couldn't. But in reality, it's not. When you get a little bit more experience in there, the rules are pretty strict and you can easily spot them. Okay, so let's move on. Second normal form. Second normal form is still the same thing. It's still that functional dependency thing, except sometimes you have a table that has a compound primary key, which means you have more than one column that's needed to make things unique. Remember that? Okay, cool. So if it has a compound primary key, then the rule basically says that all the columns have to match all of the key, not just part of the key. So they have to be related to the whole thing, not part of it. Okay, so for example, given a player and a game, so there's a primary key that has 2 parts, player and game, I should be able to tell the number of hits, runs, and runners batted in. Make sense? Okay, good. So here's an example of a bad one. So I have an item number in a warehouse. So apparently we have, 3 warehouses. I guess it's just two warehouses. We have a main and a south. And then a quantity on hand and a description. So right off the bat, you might be looking at this going, I don't see anything wrong. So the primary key is made up of both of these items. So far, so good. The quantity on hand, yeah, because the quantity on hand of 14 in the main is 0 and in the south is 40, so that makes good sense. But the description is not dependent on the warehouse. So that makes sense, right? Because if you got item number 12, it doesn't matter what warehouse it's in, that it's always an X. Make sense? So this is a violation of second normal form because the description isn't dependent upon the whole thing. It's dependent only on part of the thing. Okay? Good. Moving on. Third normal form. Third normal form introduces a new term called transitive dependency. And it's basically, you know how transitive anything works. Like, I trust you and you trust Bob, therefore I trust Bob. That's a transitive relationship. You know, like things kind of hop along. Well, that's exactly what we're talking about here. So the rules are that all columns have to be related to only the primary key. You can't have another column in there. You can't have another hop in the thing. So if some other column is being used as a key, that would be a violation, a transitive dependency. So here's a cool thing that they talk about. If you're trying to describe the first three forms, it's the key, the whole key, and nothing but the key. That's kind of cute. All right, so let's do an example. So here we go. So here's a tournament and a year and who the winner is. So right off the bat, this is a compound primary key, right? A primary key made of both pieces. And the winner, yeah, because the winner clearly has nothing to do with the year alone or the tournament alone. It has to be the combination of the two. But can't you kind of look at this for a minute and see that the winner's date of birth really should be related to the winner and not the PK? Make sense? So just kind of eyeball for this for just a minute. What they're basically saying is winner would be a better key for the winner's date of birth. So this is a transitive dependency, meaning that tournament and year determine the winner, but the winner, so you see how it does a little hop? The winner determined. So next is Boyce-Codd normal form, or BCNF. Now this is not really a new form. It's just an amendment to number 3. Number 3 is the one with the hop, right? It's the same thing. It's still the one with the hop, except there's a wording change. In the 3NF, it says that the thing in the middle, the intermediate determinant, I made that term up, is a non-key, all right? So you can't have a non-key pointing to another key. The problem is, what if that isn't a non-key? What if it's a candidate key? Okay. So they had to make some changes. So here's an example. So I've got, it should be fairly obvious looking at this. Student ID, name, account. Okay. So the student ID determines the account. But you can kind of sort of tell that the account can determine the email. All right? So this is a hop. No different than, the employee with the department and the department supervisor is still a hop, right? The problem is that the account is a candidate key. In other words, it's just as good as a student ID. By the way, email is also one. But the point here is because account is a candidate key, it doesn't meet the definition of a third normal form. So they created a brand new one. Okay? This is nothing really special, guys. I mean, for example, let's look at it this way. If you saw the hop and you want to determine whether or not it was a 3 or a BCNF, all you have to do is go to that thing in the middle and see if it's a candidate key. If the answer is no, it's 3NF. If the answer is yes, it's BCNF. That's it. And really, quite frankly, it doesn't really matter if you think about it, because in every case, you're going to have to fix it. So why make the distinction? It's kind of weird, huh? Okay, we're coming up on the 15-minute mark. It's probably a good place to break this, and we'll pick it up again in part 2.